Okay, so for today, what we're going to talk about is how do you solve radical equations? And I think the big thing is inverses. And then you got to check your answers because sometimes when you scribble sides, you get extraneous solutions that don't check because when you scribble sides, you kind of get rid of the signs. And so you have to check the answer in your original equation. So you're going to you're going to isolate the absolute value or the square root, and then by plussing the 1, okay, so you're going to move this by plussing 1 to both sides right here, and you get a minus 1, minus 1 from both sides, and then you're going to square both sides. All right, so you're going to square both sides, and then you're going to, the square and the square root undo each other, and then when you square the right side, you get 16, and then when you solve it, you get 18 as your answer. Now, you do have to check it in the very most original question. So I took this original problem, and I put it right here, and I put the value we got for 18 into here. 18 subtract 2 is 16. Square root is going to be 4, not plus or minus 4, it's just 4. Because we're, just plugging in to see what happens. You get the principal root, and that does check. So this is a valid solution. I think the big thing for the next question is when you're going to square both sides, you got to remember when you square both sides, when you square the left, the square and the, oopsie, I did not mean to do that. When you square the left side, the square and the square root go away and you're left with just 2x plus 14. But when you square the right side, you don't just square each term, you got to square the whole right side. So you have to take x plus 3 times x plus 3, FOIL it out, and you're going to get this trinomial. Okay, so that's the first thing we're going to do is square both sides. When you square both sides, the left side goes, the square and the square undo each other, and the right side you have to FOIL it out. And then you get a quadratic, subtract these terms to bring them to the right side. You get a quadratic, factor it, set them h equal to 0, get your solutions. Now notice I've crossed one out. Why? Well, over here, I've checked both answers. And so if you check the left side of the equation, or the first equation, and you plug it, you do 2 times 5 is 10, negative 10 and 4 is 14 is 4. The square root of 4 is going to be 2. But when you plug in negative 5 on the right side, negative 5 plus 3 gives you negative 2, and negative 2 and positive 2 are not the same. So that's why I crossed out negative 5. Now, sometimes both solutions will be valid. Sometimes one solution will be valid. And so you just have to check to see, is there a solution still? If you plug in 1 on both sides of the equation for x, you will notice that you get 2 times 1 is 2 plus 14 is 16, square root is 4. That does equal the right side being 4. Okay, the last one we're going to look at before we actually try these questions is going to be when there's multiple roots. And you're going to have to square both sides twice. And so it's not the end of the world, it's just not the most fun. And so isolate the biggest square root. Okay, so this biggest square root is the one on the left. So I isolate that first. When you square both sides, that one will go away and you get x minus 12. When you square the right side, remember squaring 2 terms doesn't square each term. You have to FOIL it out. And so when you do that, you're going to get kind of a hobgoblin of a mess here. And there's going to still be 1 square root here. Normally there will be just 1 square root left. Isolate that square root, okay? Bring everything else to one side and then divide by a negative 4. And you're going to get to here, and it's not that bad. Square both sides, and you get x equals 16. When you get that, you got to plug it into the very most original equation that you had to see, does it work? And the answer is it does, okay? So it's a bit of a weird thing, and so the steps are written right below here, okay? So, as we try these questions here, I think the big thing is follow steps. Isolate the radical, and then do the inverse operation. So on the first one, if we minus 4 from both sides, I'm going to make that a 9. Okay, just pretend it was always a 9. You're going to have the square root of x minus 1 is equal to 5. You've got to square both sides, so you're going to multiply the left side by itself and the right side by itself again, and that will give you x minus 1. They undo each other, equals 25. Plus 1 to both sides, you get x is equal to 26. Have to check it. Where? The most original equation. So if you go up to this top equation here and you plug in x is going to be 26, you do 4 plus square root of 26 minus 1 is square root of 25. And then you're going to see, does that equal 9? Yeah, square root of 25 is 5. 4 plus 5 does equal 9. Okay, and so that would be a happy face. So we keep that. Okay, so sometimes when you're squaring both sides, you get introduced extraneous roots because the signs change when you square both sides. It kind of things start to become positive, and that introduces additional answers. First thing is move the 3 to the other side, and you get equals on the right side x minus 3. Okay, we're going to square both sides. When you square the left side, the square root goes away. You get negative 8x plus 12. On the right side, you have to FOIL it out. So you're going to take x minus 3 times x minus 3. I'm going to FOIL it out. I get x squared, and you're going to get negative 3x and negative 3x again. So it's going to be negative 6x, and you're going to get plus 9. This is a quadratic. Haul everything to one side. Keep the x squared positive. So we're going to plus 8x to go to the other side. And I'm going to minus 12 to move it to the other side. When you do that, you're going to get 0 on the left side. You're going to get x squared plus 2x. And then, let's see, minus 12 is going to be minus 3. She will factor, okay? X plus 3, x minus 1. Okay, so that means x is equal to negative 3, and x is also equal to 1. You must check both of them, okay? It's possible they both work, possible they both don't work, possible one of them works, okay? So try it in the most original equation that you started with, okay? This one here. If you start partway down, they'll probably both work, okay? And that's not always the case. That's true. So let's plug this in for this one. If you plug in x equals negative 3, okay, let's do negative 8 times negative 3 is 24. So you're going to get 24 plus 12, and then we're going to square root it. Then we're going to plus 3 to it, and then we should get x, which is negative 3. Wait a minute. You're going to get square 36 plus 6, and you add 3 to it. How would we ever get negative 3? Okay, that negative 3 is dumb. So what I want to see is you got it, and you purposely pitched it, okay? And that does not work. Show me that you checked it. Check 1. Okay, square root of negative 8 times 1 is negative 8 plus 12 is going to be negative 8 plus 12 is going to be a 4. So the square root of 4 is on the left. Then we have to add 3 to it, and we're supposed to get x, who is 1. Wait a minute. Square root of 4 is 2. 2 plus 3 doesn't give us 1, does it? Both of these are extraneous, and we're going to get no solution. That's the deal. If you get one solution, you just say, okay, that's my solution. But if both of them go away, you write no solution. Okay, next one. This is one that it has 2 different square roots. It will involve 2 squarings of both sides. Okay, it's going to be a little disgusting, but you can do it with practice. So on the left side, when you square the left, the square and the square root go away. On the right side, you have 2 terms who have to FOIL, and you're going to have 1 remaining square root, who you will isolate and square both sides again. So don't cry too hard. You're going to get x minus 12. On the right side, when you take the square root of x, minus 2 times the square root of x, minus 2. Okay, we're going to get square root of x times square root of x is x. And then minus 2 square root of x and minus 2 square root of x. And then plus 4, okay? All right, this is really delightful. Notice the x's on both sides will cancel out. So if you minus x from both sides, one of your x's goes away. That's awesome. And these guys will combine together. And then if I minus 4, I can bring it to the other side. So I get negative 16 equals negative 4 square root of x. My goal, again, is to solve for x. Okay, this is not going to be that bad. Divide both sides by negative 4. You get the square root of x is equal to 4. If you square both sides, you get 16 is equal to x. You must try it and see if it works. How? In the most original equation. Okay, so the most original equation is square root of 16 minus 12, which is going to be 4. And then you're going to set that equal to, let's see, the square root of 16, which is 4, and then subtract 2. Hey, 2 equals 2. Okay, that's your solution. So that's a little weird, but that's going to be how you do that kind of question. When there's 2 square roots, you're going to have to square both sides twice. Isolate the biggest square root, square both sides. Isolate the other square root, square both sides. Okay, and this one, you minus 1 from both sides, you have the cube root. What are we going to do with the cube root? Well, you're going to cube both sides, okay? And then when you cube the left and you cube the right, you're going to get 3x minus 2 is equal to 4 to the third, which is 64. Add 2 to both sides, divide by 3. Add 2, 66, divide by 3, you get 22. Now here's the real deal. You should show you check it. However, if it's a cube root and it doesn't work, you botched. All the odd roots answers should work because you don't introduce extraneous solutions when you're cubing both sides. So 3 times 22 is going to be 66. 66 minus 2 is 64. The cube root of 64 is 4. 4 plus 1 does equal 5. Check. We did it right. Okay. All the odd roots should check, and if they don't, you botched it. Isolate this by plussing 4 to both sides. You get 14. Divide both sides by 7. You get the 6th root of 5m. plus 4 is equal to, dun, 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 I plus 4 to get 14 divided by 7, I got 2. How do you get rid of 6 root? 6 power both sides. You get 5m plus 4 is equal to 2 to the 6, and that's going to be minus 64. Minus 4 from both sides, you get 5m is equal to 12, and then therefore m is, oh, I lied. 5m equals 60, divide by 5, you get m equals 12. Okay, that's a 12. Not very nice 12, but it is m equals 12. Now the deal is, let me erase that because that's just, hideous. We'll fix that. Okay, so m is equal to a lovely 12. Okay, we should check it because it's even root. So 7, 6th root of 5 times 12 is 60. 60 plus 4 is 64. The 6th root of 64 is, dun, 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 2. 7 times 2 is 14. We're supposed to minus 4, and our answer should be 10, and that is the case. So therefore, it does check, and that is the right answer of 12. Okay, what does to the 1/2 power? That means the square root. So we are going to end up squaring both sides. When you square the left side, you get 4x plus 8. Remember, to the 1/2 power, it does make square root. To take 2x times 2x, you're going to get 4x squared. Oh dear, it's just quadratic, isn't it? You can divide all the terms by 4, okay, and then move those left two terms to the right. So you get 0 is equal to x squared minus x minus 2. Factor it up. Let's check to see. We get x minus 2 and x plus 1. That means x is equal to 2 and x equals -1. Got to check them out to see do either or both work in our problem. So if you plug in 2 to the original best equation that you start with, 4 times 2 is 8. 8 plus 8 is 16. 16 to the 1/2 should equal 2 times x, which is 2. Hey, guess what? That's 4 equals 4. Yay. The first value works. How about -1? I bet you it's not going to work. 4 times -1 is -4. -4 plus 8 is 4 to the 1/2. And that should equal 2 times x. X is -1. Bum, ba-dum. 2 does not equal to -2, so therefore -1 is an extreme solution. Okay, last one. Hey, here we go. We're making progress. To do this one, you're going to move the 1 to the other side, and then we're going to square both sides. When you square the left side, you get -5x minus 9. When you square the right-hand side, you take x plus 1 times itself again. You're going to get x squared plus 1x plus 1x. That's 2x plus 1. Haul everything to one side. I'm going to put it to the right, so the x squared is positive. You get x squared plus 7x, and then plus 10. She factors into x plus 2 and x plus 5. That means your x values are -2 and -5. And here we go. Let's try them. Guess what? Remember this question. She ain't pretty. Try -2. -2 times 5 is -10, or is 10, pardon me. 10 minus 9 is 1. Okay, so we have to take the square root of 1, and then we have to subtract 1, and we should get x, which is -2. 1 minus 1 is not equal to -2, so -2 is a bad choice. So that doesn't work. Take a -5. -5 times -5 is 25, and 25 minus 9 is going to be 16. 16 to the 1/2 is going to be square root of 16, which is 4. 4 minus 1 is supposed to equal -6, or it's supposed to equal x. 4 minus 5 makes 3, not -5. So guess what? No solution. And the last part is to remind you, hey, guess what? If you wanted to solve it by graphing, remember, you can graph both sides of the equations and find the x value of the intercept, okay? So you could graph in one equation, the left side, y equals, and graph on y2, the right side of the equation, okay? So let y1 equal one side, let y2 equal this other side, and guess what? Second, calculate intersection. You would get an ordered pair xy team, like -1 something. What we really want is just what x is. We're solving the equation for x, so look for the x coordinate of that intersection. So -1, 6. So the x being -1 is when they both coincide. Okay, so that makes the equation true. So that's another option for how to solve it. All right, thank you so much. Hope you have a great day.